In this video, we are talking about resonance air column apparatus, right? Use this in the laboratory to find the velocity of a sound. We use a formula. So my basic intention is how do you get that formula? Though I am not that much focusing really about experimental demonstration and experimental description. But roughly to tell you that it will have a long column which is closed at one end, open at other end. It is filled with water partially up to some extent. Here you take a tuning fork, hold it, vibrate it. So the sound comes from the top of this column and reflects back. Like I told you yesterday, there is a formation of a closed pipe wave. This is the formation of a node. This is an antinode. This is the least kind of vibration. This is called something like first harmonic. So during that first harmonic or first resonance, what do you mean by resonance is this tuning fork has the frequency n. This air column what is there above the water has also had certain frequency. So for a particular length of the air column, what happens is frequency of the fork becomes frequency of the air column. In that case, the booming sound, large booming sound comes and resonance is being heard or being felt. So large booming sound through that pipe is heard. In that case, I can write the length of the air column. This is the air column. L is distance between a node and an antinode. You know, between node and node, lambda by 2, node and antinode, lambda by 4. I'll call that resonating length as L1, or you call it as a first resonating length. That's the least possible resonance that can happen here. So at resonance, when the frequency of the fork equal to the frequency of a air column, a large booming sound is happening, right? L1, first resonating length L1 is equal to, see, oh, sorry, lambda. Wavelength lambda is equal to, sorry, I have missed this, right? Yeah, I have said it wrong, right? Let me just correct it. Here, first resonating length L1 is equal to distance between node and antinode, that is lambda by 4, right? So L1 equal to lambda by 4. From here, I got L1 equal to lambda by 4. First resonating length is the distance between the node and antinode in a fundamental mode of vibration. So L1 is equal to lambda by 4. There is so I can repeat this experiment again by lowering this water level, by increasing the length of the air column. In that case, what happens is the same experiment we do repeat, but we reduce the water column and increase the length of the air above it. This is the length of the air. So what happens in that case is when you take the same kind of a tuning fork, I repeat that we take the same tuning fork like we have taken the same N. So when you repeat the experiment with the same tuning fork N and vibrate, that vibrations will pass over this bottom of the stretcher string. Here a formation of a node happens. The next kind of vibration do happen like a node, and at the top there is an antinode. So for a particular position of the air column, again for the same fork, large booming sound is heard. Large booming sound is heard. So what happens at that large booming sound is the length of the air column is now different. We can call it like L2. is the distance between a node and node, that is lambda by 2, node and antinode lambda by 4. So the total length is lambda by 2 plus lambda by 4, that is 2 is LCM, 3 lambda by 4. That's the second resonating length. I know L1 and L2. As I know L1 and L2, so this is equation number 1, equation number 2. L2 is definitely larger than L1. So let me like L2 minus L1. That is 3 lambda by 4. 4 is LCM here. Minus lambda by 4. That is 2 lambda by 4. That is lambda by 2. So L2 minus L1 is found as lambda by 2. Lambda equal to 2 times of second resonating length minus first resonating length. We know velocity of a sound is n lambda. So n into lambda is this much, 2n times of L2 minus L1. So in this experiment, we can find velocity of a sound using this formula. V equal to 2n into L2 minus L1. My core aim is to tell you that from where you get this formula, what's the derivation of this formula. My intention is that. That's why I have not focused that much on experimental derivation, the experimental explanation, that how do you do experiment. That you can find in another video if required, but it's not a serious part of our syllabus. Rather, it's a part of the lab. Probably you will get it in our laboratory. So we use this formula in the laboratory manual. I want to tell you from where you are getting that formula. So we use the tuning fork of known length. We first find the first resonating length by reducing the length of the water column. By changing the length of the air column for a particular length, you get a large booming sound. That's first resonating length. You repeat the experiment with same tuning fork by lowering the water column and increasing length of air column. Where you get the second length is called something like a second resonating length. Earlier first one is the first resonating length is L1. L2 is the second resonating column. Second length of the resonating column. That's what you do in the laboratory. This is the formula you use. This is the reason for that formula. Right? Thank you for watching.